So today we're learning about radicals and rational exponents. Radicals are these little square root looking signs, and rational exponents is basically when you have a fraction as an exponent. So if you remember about exponents, like 2 to the third power means 2 times 2 times 2, right? So 2 cubed is 8. And then you can undo that cubing by taking the cube root. So the cube root is the opposite of raising to the third power. The cube root symbol is basically a radical with a little 3. It's saying what number would you multiply by itself 3 times to get 8, or what number would you cube to get 8? So the cube root of 8 is 2 because 2 is the number that you cube to get 8. So we're going to talk about a few things today. We're going to find nth roots, talk about what an nth root is and how to find it. We're going to evaluate expressions that have rational exponents. And we're going to look at some real life applications for rational exponents. So we can extend the concept of a square root to other types of roots, like we just saw with 2 to the third power being 8, and then 2 is a cube root of 8, right? Because 2 cubed is 8. 3 is a fourth root of 81 because 3 to the fourth power equals 81. And one thing that we're going to do to make this a little bit easier to keep track of is we're just going to make a chart of powers that will make it easier to go back and forth between powers and roots. So in general, for any n greater than 1, if b to the n equals a, then b is an nth root of a, because b, you raise it to the nth power to get a, so b is the nth root. And it's probably easier to see a bunch of concrete examples first, like 2 to the third power is 8, so 2 is a cube root of 8. Okay, now this part up here is kind of an important concept to get, that the nth root, you can also write it as a power of a. Like the square root is the 1/2 power, because if you square that, remember when you do a power to a power, you multiply the exponents. Hayden, can you guys keep it down during the lesson, please? Please pay attention. All right, so we've got if you have power to a power, you multiply, right? So 2 times 1/2 is 1. So when you square the 1/2 power, you get a back. So that means that the square root is the 1/2 power. The cube root is the 1/3 power. The fourth root is the 1/4 power. And so to generalize that, the nth root of any number is that number to the 1 over n power. So here are some core concepts that need to be in your notes. If n is odd, so if we're taking the odd numbered root, then a has one real nth root. So if you're taking like the cube root or the 5th root or the 7th root, there's only going to be one real root. But if n is even, if we're doing like the square root or the 4th root or the 6th root, and we're taking the root of a positive number, then it has 2 nth roots, 2 real ones, a positive one and a negative one. So like if you're taking the square root of 4, technically there's 2 real roots. There's 2 and negative 2, because 2 squared is 4 and negative 2 squared is 4. Negative 2 times negative 2 is also positive 4. If you're doing an even root of 0, it's just 0. There's only one real root. And if you're doing an even root, so like the square root or the 4th root of a negative number, there's no real roots. So you can't do like the square root of -4, at least not during algebra 1. You have to learn about a different kind of numbers, and you'll learn about those in Algebra 2. Okay, so let's look at some examples here of finding real roots. So find the indicated nth roots of A. So n is 3, so we're looking at the cube root of negative 27. So if we go back to our definition up here, we're doing the odd root of a negative number, right? So n is odd, then A has one real nth root. So we know we're only going to have one real root here. But what number would I multiply by itself 3 times to get negative 27? If you do negative 3 times negative 3 times negative 3, that gives you negative 27. So the cube root, so you could rewrite negative 27 as negative 3 to the third power, right? And then the cube root and the third power then cancel each other out essentially. So you just get negative 3 as your real nth root of A, the real cube root of A. But when we're looking at B over here, now we're doing the 4th root of 16. And we have to remember that when you're doing an even root, if n is even and you're doing it to a positive number, then you get 2 real nth roots, a positive one and a negative one. So the 4th root of 16, what number is there a number that if you raise it to the 4th power, you get 16? That number is 2. 2 times 2 times 2 times 2 gives you 16. But since we have the 4th root and it's a positive number, we have to remember that it's plus or minus 2. So there's 2 real roots there. There's positive 2 and negative 2. Because positive 2 to the 4th equals 16, but negative 2 to the 4th also equals positive 16. Because there's 4 negatives that you're multiplying, so your answer will be positive. So remember, when it's just asking you in words to find the nth roots, you have to remember how many there are. If it's an odd power, there's just one, and it matches the sign of what's inside the radical. If it's an even power of a positive number, you're going to get 2 roots, the positive and the negative. If it was an even power of a negative number, there's no real roots. So if they asked us on a question like this, if they said find the real roots here, and it was like 4th root of negative 16, there's no number that you multiply by itself 4 times and get something negative. So this one, there's no real roots. Okay, so now when you see the radical sign here, the radical sign indicates only the positive square root of A. Before, when it was in words and it said find the nth roots, you could have positive ones and negative ones. But the radical sign indicates we're only looking for the positive root. So if you see the radical sign with an nth root, if that's an even index, if n is even, we only want the positive root. If n is odd, then the answer could be it'll match the sign of whatever A is. If A was negative, then the root would be negative. If A was positive, the root would be positive. So let's look at evaluating these expressions. So when you have the radical sign, you're only going to get one answer. If you have an even root here, you're only going to give the positive answer. So cube root of negative 8, What would you multiply by itself 3 times to get negative 8? Negative 2 times negative 2 times negative 2, so negative 2 to the third power. So the cube root of negative 8 would be negative 2. Negative cube root of 8. Now you got the negative outside cube root of 8. The cube root of 8, 2 times 2 times 2 is 8. So this is negative 2. And then now the negative can get reattached to the 2. So that's also negative 2. Right here, 16 to the 1/4, that's the fourth root of 16. And 16 is 2 to the fourth power. So the fourth root of 2 to the fourth would be 2. And then on D, we're looking at the fourth root of negative 16. And there's no real number that you can raise to the fourth power to get something negative. So this has no real root. Okay, so here's the core concept for your notes. Rational exponents don't have to be only in the form 1 over n, right? They can have something besides 1 as a numerator. You can have fractional exponents such as 3 over 2. And so the thing that we have to realize is, what does that mean? So you notice with 1 over n, n was the root. 1 over n power, we did the nth root. So that's going to stay the same. What happens is the number on top becomes like the new exponent, and the number on the bottom is the root. So it's like the top number is that's the power, and the bottom number gives you the root. And generally you want to, you have to just do one, you have to raise it to the power and then take the root, or take the root and then raise the answer to that power. It's usually easier to take the root because that gives you a smaller number and then raise that to the power instead of the other way around. So in algebra, you got like this, a to the m over n is, so basically what you do is that's the nth root, and then you raise that to the m power. So if we were doing, for an example, in a number, 27 to the 2/3 power would be with the 3 on the bottom, that's going to be the cube root. And then the 2 on the top, that's going to be the exponent, the power, right? So the cube root of 27 would be 3, and then 3 squared would be 9 for this one, right? So 27 to the 2/3 power would be 9. All right, let's look at some examples evaluating 16 to the 3/4 power and 27 to the 4/3 power. Okay, so 16 to the 3/4 power. The number on the bottom of the fraction is our root. So this is going to be the fourth root of 16 raised to the third power. So the fourth root of 16 is 2, because 2 to the fourth is 16. So now we're doing 2 to the third, which is 8. So 16 to the 3/4 power was 8. Right? We took the fourth root and raised it to the third power. For part B, the denominator of our exponent fraction is a 3, so we're doing the cube root of 27. And that gets raised to the fourth power. Cube root of 27 is 3. And 3 to the 4th power, 3 times 3 times 3 times 3 is 81. So when you see a fraction power, you do the bottom, the denominator, that's the root you do, and then you raise it to the power of the numerator. And then we can use fractional exponents to do some real life applications too. For example, here's an equation that gives you the radius of a sphere based on the volume. And here's the big old beach ball that has a volume of 113 cubic feet. And we can use this to find the radius. And we'll use 3.14 for pi. So what we're going to do, we want to solve for the radius. That's 3 times v over 4 pi to the 1/3 power. And v, our volume is 113. All right, so I can do the multiplication inside here. Three times 113, 339. I'm going to divide that by 4 and pi, right? So I had divide by 4 first. Then I'm going to go ahead and divide by pi, which is, we're going to use 3.14. And we get about 26.99. To the 1/3 power. But the 1/3 power is just the cube root, right? So this is the cube root of 26.99-ish. And this calculator doesn't have a cube root, but I can switch it to scientific. And that should have a cube root in there somewhere. Or we can just do the fraction power, right? We can do 26.99 to the, and then I'm going to put fractions 1 divided by 3. That's not a 3. Starting over. I clicked wrong things. 26.99. Well, can you tell what the cube root is going to be? Because it's really close to 27, so this is going to be really close to 3. To the 1 divided by 3 equals, so 2. So the cube root is 2.9999999, which is really close to 3. So the radius of this thing is about 3 cubic feet. So about 3 feet. Okay. So we looked at fraction exponents. The denominator is the root. The numerator is the power you raise that root to. And we looked at roots. If it's an odd numbered root, you only get one answer, and it matches the sign of whatever's under the radical. For even numbered roots, you can only do even numbered roots of positive numbers. And there you go. That's the lesson. So make sure you turn in your notes as soon as possible, and I'll get this video posted as soon as I can.